Hello everyone! I am now halfway done with my nuclear chemistry summer program. I think a lot of people have misconceptions about what exactly radiation is. People usually think about glowing green sludge and terrible disasters and genetic mutations and the Incredible Hulk. But most people don't know exactly what it is. I'll start with the atom. An atom consists of three parts: protons, neutrons, and electrons. The protons and neutrons exist in the middle, called the nucleus, and the electrons orbit around the outside of it. Chemical reactions have to do with the interactions of the electrons, but nuclear reactions take place in, well, the nucleus. When an atom undergoes a nuclear reaction, some sort of particle or wave is emitted. This is called radiation. There are four main types of radiation: alpha, beta, gamma, and neutron. Alpha radiation is when an alpha particle is emitted, which consists of two protons and two neutrons. The alpha particle breaks off from the parent nucleus, which then leaves behind a daughter nucleus. The daughter nucleus is a different element than the parent nucleus. For example, uranium-238 releases an alpha particle, and what's left is thorium-234. Alpha particles have a lot of energy. However, they're, relatively speaking, very large particles. They can be stopped by a piece of paper or even the outer layer of dead skin. Alpha radiation is only really dangerous if it gets inside your body. It's still not a good idea to handle things like uranium, because even though the alpha particles aren't that dangerous, the daughter nuclei are often radioactive. In the case of uranium-238, the daughter nucleus is thorium-234, which emits beta radiation. Beta radiation is when a nucleon, which is a fancy word for a proton or a neutron, turns into a different nucleon. In beta minus decay, a neutron turns into a proton, which then emits an electron and an antineutrino. In beta plus decay, a proton turns into a neutron and emits a positron and a neutrino. Neutrinos and antineutrinos don't really do that much, so when we talk about beta radiation, we focus on the electron and the positron, which are collectively called the beta particles. Beta particles have high energy, but they can be stopped by a piece of plastic, aluminum, or water. One really cool effect of beta particles in water is Cherenkov radiation. Beta particles travel really fast, so when they hit the water, they have to slow down. This then releases ultraviolet rays and blue light. Here's a picture I found on Google. This is why, in TV and movies, radioactive material glows. The next type of radiation is gamma radiation. Sometimes the nucleus of an atom is in an excited state. The nucleus decays to a lower energy state because of the law of conservation of energy. That difference in energy has to go somewhere, and is therefore emitted in the form of a gamma ray. Gamma rays don't have mass, so they can get through just about anything. The most effective shielding against gamma rays is lead. But even with lead, not all gamma rays can be stopped. However, the most penetrating form of radiation is neutron radiation. Neutron radiation occurs during fission and fusion reactions and can only be stopped by large amounts of water or a whole lot of concrete. A fission reaction is when one large nucleus splits into two smaller nuclei. This releases neutrons. This is the type of reaction that happens inside a nuclear reactor. They take something like uranium-235 and they fire neutrons at it. This causes an induced fission, which then splits the uranium into two daughter nuclei. This reaction releases a whole lot of energy, and then also neutrons, which then trigger more reactions. After that, nuclear power plants work just the same as any other power plants. The heat generated from the reaction heats up water, which then boils to form steam, which then turns a turbine, which then spins a generator, which then produces electricity. The other type of neutron reaction is fusion. Fusion happens when two small nuclei fuse together to form one large nucleus. This reaction can't be controlled well, which is why there are no fusion power plants yet. But if you just want to destroy stuff, fusion works really well, and it's what's used in hydrogen bombs. However, there is one great fusion power source nearby: the sun. That is what stars do. They fuse hydrogen atoms together to form other lighter nuclei, like helium. And this releases a tremendous amount of energy. That's actually how all the stuff in the universe was made. Originally, the only atoms in the universe were hydrogen atoms and a few other light nuclei. But then they were fused into other light nuclei in stars. However, when a star goes supernova, they have enough energy to create the heavier elements, which are then launched into space. The heaviest star-created element is uranium. All of the elements on the periodic table after that are either a result of nuclear reactions, or they were made by scientists. So, everything in the universe is a result of nuclear reactions. They're also a pretty cool source of power. I'll probably end up talking about something like this again, so please let me know in the comments if you have any questions. Please like and subscribe, and come back for Emily's video tomorrow. Bye!